So here we have the football display. Hi.
Hello.
So please introduce yourself.
So I'm Dr. Aditi Majumdar. I am a professor for 20 years in UC Irvine. And this technology, Summit Technology Laboratory startup, is a deep tech which is translated from my lab to become this company.
And there's a bunch of projectors on the football right here, the American football.
Yeah. So I'll tell you what we are doing here. We call this liquid light. Just as liquid flows around the object, we imagine the light kind of flowing around the object and adapting to any kind of shape. So here you see football is a complex shape. You have 6 projectors here, which is projecting on this football together, creating this immersive, seamless display. We are a software company. What we are developing is a software which makes this creating of a seamless display extremely easy. So this in the industry is known as projection mapping. For example, if you go to an event like Van Gogh, or you are seeing an immersive environment in a museum.
Usually it's on a big screen and that's different angles and
Exactly, exactly. So we also do big screens. We have brought this here, portable display, but you can see in this video. So basically what happens is when you have multiple projectors and you have to put them together to create a display like this, it is usually very hard. Currently, the state of the art is a more or less semi-manual, semi-automatic kind of process where you may have to have a LiDAR brought in to scan the surface, or you may need to have markers on your display, and or you may have a person really sitting there and putting up grids on the projector and manually trying to align it and make it seamless. What we are showing you here is a singleton software that uses cameras in the loop, and using this camera we use our patented computer vision and AI algorithms to project to capture some patterns projected by the projectors, and using the analysis on that patterns automatically figure out how we should project content so that everything looks completely seamless. Right?
And if the ball moves, it readjusts, or what does it do?
So if you want to change the shape, or if you want to move things, you can just again press another button, and then it will basically recalibrate in another few minutes. So we can actually show you the recalibration using another vase, another object. But before that, I would like to show you some interaction. We can
this is
now.
Your software?
Our software, so it depends on the function. One of our softwares is this here. This will remotely connect to the system. It'll launch the software to start the cameras and projectors for the calibration process. We'll show this one later, but first we want to show interaction. For that, I'll be launching a different software.
All right, so you have interactivity potential. It can all be done in real time. What could it be running on? Like a big computer under or something?
So no, below we have a PC. Okay, so the PC is essentially connected to all these projectors and the cameras. It's a consumer level PC with NVIDIA GPUs. With a good GPU, exactly. And then it is creating all the, we'll show you the calibration process in a minute, but right now you see it is creating a digital twin of this object when it calibrates, right? And that calibration process has exactly figured out what is the shape of this object. And now in our interaction software, we are connected to that PC, and now it is loading that 3D object. And Sasha, you can tell more about this.
Yeah, so here's that 3D model for the object that we've reconstructed during the calibration process. So you can see it's that same football. I can preload textures onto it, so you can see as I apply things on the interaction program, it's also on the football. Here I will go ahead and let's draw some birds in the sky. And as I draw in real time, it is also drawing on the football. So I'll also write STL, our company abbreviation, at the bottom there. You can see it's all updating in real time. and this is just a touch screen tablet.
Do you want your picture on top of that?
Yeah. So you can put any picture you want from the webcam?
Correct, yeah. So I'll go ahead and capture a photo of you if I may.
Yeah. All right.
Nice. And then it'll now get sent to the
I
football.
put my face on the ball.
Yeah, and you'll see yourself.
That's me. And it's the same shape like my face a little bit.
Launch
Yeah.
the
All right.
laser also. And then, this is one form of interaction, but we can also interact with it using a laser pointer. So when you have a large display like we were showing you there, right? Then interacting with it with a mouse or a keyboard becomes a little cumbersome. So we can show you a laser interaction on top of this.
So do you sell this software?
So currently we are actually licensing this software with the annual license and support model. We have captured a few customers, but we are now post-product and trying to commercialize it. So we are a startup company who are trying to commercialize this. But this is the first time a projection mapping software can really be SaaS, right? We are trying to put it, go towards a model where we can put it in the cloud and it can be a completely SaaS model. So here you see that, we have loaded the Google Earth.
Yeah, so this is Google Maps, just played via Chrome, and I have a red laser here. The cameras are going to be able to pick up this laser, and so you can see I'm dragging Google Maps, and it's acting as a mouse, the laser. And basically anything the mouse can do, so I'm double clicking to zoom in, and you can triple click to zoom out. You can basically replace the mouse and interact with any object that you place in here.
Cool. So there's only a question of imagination what can be done, right?
Exactly. So now we are going to actually, you can see this is actually a completely calibrated system that we are showing you. So if you notice, right now if I do this, right, so this is a calibrated system. So if you notice that this is a projection, and because the system knows what is the shape, it only projects on the football, and this spillover light is actually completely blackened out, and so you are not blinded by the display. Okay, now if he goes, what will you do, Sasha? You are going to go back and put it into fractive setting, right? So now what he will do is he will not use our software. He will take it back to what it would do if it was no software used. And
These are DLP projectors?
This can be any projectors. We are hardware agnostic, we are content agnostic, we are shape agnostic. So you can
be one that has a nice, dark levels. So you don't.
So the black offset levels are important, but we are also working on that, and we are started to getting very good results with that also. So now if you see here, now the whole projection is showing up, right? Because it is and you are blinded probably with it, right? Because it is no longer able to, to give you. And now what we are going to do is we are going to show you that if we just change the object, and as you notice, we are not going to put any marker here, nothing. We are roughly positioning it in the center of the display. Our projectors are also usually roughly positioned, and we don't have any information of the system, and it will now calibrate in 4 minutes.
Yeah. So this is that same UI that I showed you before. This is displaying the status of the devices. So we can see we have 8 cameras. Everything looks good to me. So all I'm going to go ahead and click is run everything, and it's going to start the whole process.
Nice. It does some patterns that it can recognize.
So now with these patterns, for example, using these patterns, we can figure out how much is the ambient light in the environment. So that way we don't need to switch off the lights when we are doing the calibration. We can figure out exactly where the projection needs to be projecting so that we can turn off the pixels where the light is spilling over, so you are not blinded. Then you will see some patterns coming up, and we are going to use that to find the exact digital twin of the shape. So what that means is we are going to create a digital twin of that which is exactly correct to the physical object, because otherwise you will see problems when you project on top of it. And this will continue happening. Now there are so many other projectors coming up. And here, if you notice, I will show you some things here which will be interesting. So this is actually showing, give me 1 minute.
What's great is that some of the latest GLP pico projectors, very affordable. So you can buy 8 of them for not too much.
Yes, and you can.
How many do you use, Layer?
Here we have used 6 of them. So these are some of our commercial installations. This is the inflatable dome where you can experience a football match from inside the field, right? This is a science museum where instead of an IMAX projection, they used 3 projectors and made it seamless using this. And this is a simulator with 4 projectors. And then we'll show you some bigger ones we built for the military.
All right, so still calibrating here and running your algorithm. So, do you have a big vision for the smart projection industry?
Of course. I have been in this domain for the last 25 years. This has been almost my life's research. And I do imagine that projection mapping would go to a level where people don't need to worry about, oh, after I put the projector, what I need to do. So if you know in Sphere in Las Vegas, they have built this Sphere, $4 billion with panels. Because it's so hard to think, how are we going to correct these projectors? And so let us just use panels because they're easy. But it's not a democratic solution, right? So we really imagine using projectors to do this kind of stuff.